we talked about function combination, adding, subtracting, multiplying, and dividing functions, but there's actually another operation we can do with functions, and it's called function composition, or composing two functions. Now, here's the definition. Okay, so we see that the composition of f and g, it's denoted with f open circle g. Okay, so the notation is a little different than we're used to. And so then we say when we do f composed with g, that's the language we use. It is saying into the f function we insert g of x. So that's a little weird. Okay, and then when we talk about the domain, the domain is honestly the most complicated part of this entire process. But it says it's the real numbers x in the domain of g, and we also need to check that g is in the domain of f. Okay, language. Yeah, this is weird. So here we go. When we do a normal function, right, when we have f of x, what this is really saying is we take x, we run it through this function f, and we get an output. That's what we normally do, right? Now, when we do f of g of x, okay, so what this is really saying is, okay, well, we kind of have to work from the inside out, PEMDAS, right? So we have to do x, run that through g, the function g, and we're going to get g of x spit out at us. After that, now we're kind of at that level, so then this we have to run through the f function, and we get f of g of x. Okay. Now, when this comes into application, we'll actually see in class. So be patient until then. Okay. Now, like I said, the algebra here, it takes a little bit to get used to, but we eventually get the hang of it. For the domain, it is kind of tricky. So here, there's kind of two pieces we need to satisfy. First, we need x. So we need to look at the domain of g. That's really the first thing. That's this part. The second part says g of x needs to be in the domain of f. So we need to look at the values g of x such that f of g of x is defined. Okay, now this in practice, the first one's really easy to do. We've been doing that in the other videos. That's fine. The second one, this is not exactly easy for you to do math, or the language gets in the way of understanding how to do this mathematically. My own shortcut, which it's kind of circumventing the whole thing, you really shouldn't do this, but we're going to do it, is to say find the domain of the composition. So to find the domain of the composition, this is why it's poorly defined. To find the domain of the composition, you have to first do the composition, which you hope works, and then you go back and say, oh, what values of x make it work? Okay, so we need to check these two things. Find the domain of g, find the domain of f, and then make sure that we intersect the two, that we find the values that are common to both. Okay, so let's see this. I'm going to do the first one, you're going to do the second one, and then we'll do the third one together. Okay, so f of g of 2. Okay, so this, we don't have to worry about domain yet. Whew. So again, this is saying f of, and f of g, and then 2 inside. Okay, so now this part isn't too bad. Again, work from the inside out. Do g of 2 first. So I get f of, well, that's going to be pretty nice, just 1, right? And then f of 1, we plug that in, we get 7. Whew, easy. Okay, work from the inside out, remember the definition. Okay, try g of f of minus 3 on your own. And here's the function, or here's the value of the function, minus 1/3. Okay, f of g of x and its domain. Okay, so now this one, let's just do the composition first. So if I do f of g of x, this is saying, okay, into the f function, I need to spit in 1 over x minus 1, which is going to be 3 times 1 over x minus 1 plus 4, which is going to be 3 over x minus 1 plus 4. Now I could, find a common denominator and all that. I'm not going to. Okay, but now I need to look at the domain. So g of x, the nice thing about this one, so if I look at the domain of g, that is going to be all real numbers except 1, yep. Okay, and then if I look at, now this is the composition, right? So the domain of f of g of x, that's going to be defined even if I were to find a common denominator and all that jazz. Really, this is just going to be all real numbers except 1. So then if I were to officially state the domain here, what I would say is that it's going to be all real numbers except 1, or equivalently in interval notation, negative infinity to 1, union 1 to infinity, and I would be done. Okay. Now, for f of g of, or g of f of x, you might be thinking a certain thing. I want you to do the composition on your own. Take a shot at the domain if you want, and we're going to come back and talk about the domain when you resume the video. Alright, and here we go. Domain, when you do the composition, I ended up with 3x plus 3, right? Because into the x spot, which was there, I just inserted 3x plus 4. Great. Moving on with our life. Okay, domain. So I first need to look at the domain of f, which, domain of f, that was pretty nice. That was all real numbers. Okay. And now I need to look at the domain of this. So the domain of this, I know that x cannot be negative 1. So then when I state the domain for the composite function, domain of f of g, this is g of f, we get, so we have to combine or intersect the two. So it's going to be negative infinity to negative 1, union minus 1 to infinity. Okay, so there we go. Now, the reason I chose these two is that you might have been thinking that, oh, we have f of g, and that's going to be the same as g of f. No. The order is very, very important. Okay, and in general, these things are not equal. Okay, you could find instances where they're equal. That could happen. Okay, and I'm going to leave you with this example. So I want you to pause the video, find g of f and its domain, and when you are ready, continue on with the video. And here's the solution.